Example 7. Deriving parametric equations for a cycloid. The curve traced out by a point P on the circumference of a circle as the circle rolls along a straight line is called a cycloid, as you can see here in figure 13. If the circle has a radius r and rolls along the x-axis, and if one position of P is the origin, find the parametric equations for the cycloid. So here's a circle, and we can see that it's rolling along the x-axis. Now, if we take a picture of one of the circles, here it is. We can see that we have the radius r, we have a center, and we have a point on our circle called P. Now we're going to investigate that a little bit further. So, now we're going to choose as parameter the angle of rotation theta of the circle, where theta is equal to 0 when P is at the origin. Now, suppose the circle has rotated through theta radians. Because the circle has been in contact with the line, we see from the graph that the distance it has rolled from the origin is the following. So from here, we're going to be going from, here's the circle from the origin, and the circle has moved. And so we have this arc here at PT. So from the graph, we can see here that from OT, and that would be the magnitude of OT, is also equal to this arc that goes from PT, so arc PT, which also equals r theta. And so therefore, we can see that the center of the circle is at r theta, r, and so we're going to let the coordinates of P be x, y. So then, in order to find this distance here for x, then that means x is going to equal the distance of OT and subtracting the distance of PQ. So we know that the distance from OT is r theta, so that means that this is equal to r theta minus, now PQ is equal to r times the sine of theta. So that's minus r times the sine of theta. And so for y, we have the distance from TC, and we want to subtract the distance from CQ. So the distance from T to C is the value of r, because that's how we get to the center, so that's r, minus, now CQ is going to be r times the cosine of theta. So now let's go ahead and then solve. So we know that x, we can factor out r, and we're left with theta minus the sine of theta. And then for y, we can factor out the r, and what's left is 1 minus the cosine of theta. And so therefore, the parametric equations of the cycloid are the following, and we can call this definition number 1. We know that x is going to equal r times theta minus sine theta, and y is going to equal r times 1 minus the cosine of theta, where theta can be any real number. And so let's go ahead and summarize this. So what it basically states is that one arch of the cycloid comes from one rotation of the circle, and so is described by theta being in between 0 and 2 pi inclusive. Although the equations above were derived from the above figure, which illustrates the case where theta is in between 0 and pi over 2, it can be seen that these equations are still valid for other values of theta.